Alright, so if your residual plot shows that there's a pattern and you need to do what's called a transformation to make that data linear, these are some of the transformations you can do. So the first one is a quadratic transformation, okay, where if your data points sort of slowly stretch up off into the distance, you can actually stretch these x values out by doing an x squared transformation. You can stretch these lower x1s by doing an x squared transformation as well. Okay, so which you can stretch the outer x values out trying to make something linear using an x squared transformation. If your plot looks like one of these two ones here, where it sort of peters off, it doesn't disappear off into the distance, it peters off, it doesn't keep disappearing, then you might need to stretch your y values, and you do that using a y squared transformation. Okay, so that's the quadratic transformations. If we go down the page, you can do logarithmic or reciprocal transformations also. Okay, so if these data points disappear well out to the side, and I know that looks similar to the quadratic one we just looked at, you can actually bring the x values back in by doing a log x or a 1 on x transformation. Okay, and the same with this one over here. If you've got a heap of data points out here, you can actually squish them back in to try and make it look linear. If you need to compress the y values, if your y values are starting to disappear, you can compress them using a log y or a 1 on y transformation, and the same with this graph here. You can bring these values down by doing a log y or a 1 on y transformation. Okay, so we're going to run through an example of a transformation. You can see on the table on this page that there is data, and I've got that data from somewhere, and I'm going to perform a regression analysis on it. And I've already got that data onto my calculator as well, which you can see here. I'll just zoom in a little bit. So you can see the data's there, okay? And I've even gone to the effort of drawing a graph. Now there are a couple of ways I would go about this. The first thing I would do myself is I would perform a regression analysis over here. So I'm going to fit a least squares regression line over here, stat calculations and linear regression there. Okay, X list is day and y list is units, and then and the other thing to take note is it's storing that equation in F1 because I might want to use that later. Then I'm just going to press enter and it'll do it. So here I have a regression line with a data set with it. Okay, so I can then use that to go and graph that regression line on here. So there's our regression line. Okay, now I'm going to get the residual plot up. So menu 4, 7, 2, and we get the residual plot. And you can clearly see there is a strong pattern in that residual line there. Okay, so that means chances are my data is non-linear. I'm going to need to apply a transformation. So what I'm going to do is I'm going to hide that residual plot for now, because I will come back to it later. I'm going to head back over to here. Now, what I'm going to do is I'm going to perform an x squared. If we go back and have a look at our graph, you can see that these data points up here, probably to fit the line, need to be pulled out this way, so off the edge of the calculator out here. So I'm going to perform an x squared transformation. So I go back to my table, and over in F here I'm going to say that that is day squared. So I'm just going to give it a name so I know what it is, and I'm just going to go day SQ. Okay, and in here I can actually type in equals. Okay, by pressing enter it gives me day squared equals, and then I can press variables day, and then I'm going to square it and then press enter, and you can see that's given me that new data set there. And from there I can actually perform another regression analysis. So over in here, so statistics, stat calcs, linear regression, and I can choose my X list as day squared, and my Y list is still units, and press enter, and it'll come up with another regression line. And I can compare these regression lines straight off the bat. using this R value here. So 0.97 for the new regression line and 0.89 for the old regression line. So at first glance, you would say that this regression line is much better. To check and confirm that, what we can do is change the units for x to x squared, and that will change this regression line straight away. Now if I get my residual plot back up, menu 472, you can see there's still a slight pattern in the residuals, but in general the residuals fit the line a lot better, and you can tell that from the R value back over here as well. Okay, so comparing the one we did first at 0.898 to the one we did second at 0.970, it's a much better fit. So that's how you do transformations on the calculator.